Okay, well, welcome in everybody. This is our Design 300 lecture. It's Thursday, October 21st. It's 10 a.m. and we are on a Google Meet right now. So, welcome in. I wanted to just, before we jump into the lecture today, I just wanted to just review. We've been working on systems. We did the soil systems and the utility systems and the flooring systems and the building pad and things like that. So we're working on the systems of a building, moving from the bottom up. And the system that we're on now is the building envelope, which for us, we're going to limit it to walls, doors, and windows. But let's take a look and see what else comes up. After that, we've got the roofing system. And on the whole, that's what we're going to finish dealing with. So we'll finish with the roofing system in a few weeks. And then we have what to do with these things. So we're going to talk about how each of these systems affects the energy usage or the need to provide energy to a building. They each have their own aspect to the energy analysis, and we'll be able to look at things specifically and do some work using something called eQuest. You can even do it in Revit. Then we'll look at sustainability. That's a very important thing for our design mentality is sustainability. And what does that actually mean? We'll talk about what sustainability means and how to analyze your design for sustainability. And then, of course, we need to work on preventing damage. And as we're talking on building envelope, we talk mostly about water, pest, and fire. Those are the three big sources of damage to a building. So there we go. So we'll talk about preventing damage, and then we'll take week 15 to review, and then your final portfolio presentation. So we're moving along. We're doing good work. It's all there and available to you in the calendar. But right now, we're going to finish up our discussion of the building envelope, which is walls, doors, and windows. And on Tuesday, we went over some of the activities that you could be doing, how to use Revit to put many details onto one sheet, and how to use Excel or spreadsheet functions to do material resource estimates. We did not do labor this time. Labor is way all over the place. You really have to know your design to do labor. So we're going to skip labor this time. So let's see what we've got going this lecture. Hopefully you watched the playlist to talk about that shows flashing and waterproofing and getting things square and things like that. So what we haven't done so far is the building envelope systems. So let's take a look at that and just go over it in general. So what is the building envelope? It's the walls, windows, and doors. For us, that's what we're limiting it to. It's the introductory class. And the major design concerns, which we just talked about, are water and water vapor control, air control, and the thermal envelope. And so the materials that you use are going to have a big effect on that. We'll look at that when we do our analysis. But for now, we're going to be talking with water and vapor control are the wraps and the sealants that get used. For air control, again, there's something called tightness, there's air conditioning, there's ventilation, all sorts of parts to that. And your doors and your windows are key components of your air control, and they're key components of your thermal envelope. Lots of heat goes in and out of doors and in and out of windows. And it's hard to control because sometimes they're open, sometimes they're closed, sometimes it's light, sometimes it's dark. So those are major design concerns, and architects spend a lot of time on this. Now, an architect might also be dealing with the structural, but sometimes that's the structural engineer that's doing that. The architect might be concerned with the soil and the building pad and the utilities, but often that's the geotech or the civil engineer that's dealing with that. The architect, of course, is responsible to pull all of that together. The architect is often the head coordinator, as it were, of the entire project. And most often, the architect is responsible for the quality control of a project. And this is where quality control meets the consumer, the owner, the buyer, the person who's using, the user. So sorry about that. So this is a major effort for architects. Now, as we discussed very briefly before, in Northern California, we're mostly working with stick wood framed structures for our residential, something that you see right here. Studs and sheathing and joists and headers, top plates and sill plates, all this kind of stuff. And we're good at doing that. Okay, we have a lot of information. We have tons of resources. We have Western Wood Products Association. We have the APA. We have tons of information about wood itself and the stresses that wood can take and what it's like when you're across the grain or with the grain and how many nails need to be put in for it to be structurally sound and when to use these little plates you see up here and when to use bolts. So there's a ton of data about those. For light commercial, we often see these light metal frames. Okay, and that metal can be steel or aluminum mostly. And they're thin, but they're often in the shape of what's called a Z bar or a C channel. Those are the two most common. And the reason that channel is there is to give it strength in the sideways direction and give you a place to drive a screw or a rivet. The other for light commercial is a tilt-up. Now, right now, in the tilt-up world, if you get much more than 2 stories, you're starting to have some stability and connection issues to think about. I have seen these go to 3 stories, not much more than that with tilt-ups. If they're going more than that, they're usually concrete panels that are being hung on a steel frame. And that's pretty common. But tilt-ups give us a lot of advantages. So, first of all, concrete takes a long time to absorb energy and pass it from the outside of the building to the inside, or the inside to the outside. So that can be really good in some environments. It can be a difficulty, as an example, though, if your environment is one where at nighttime the building is still going to be used, because nighttime, when it cools off outside, your building starts radiating all that heat it built up, and it radiates it both inward and outward. And so you can maintain rather high temperatures inside during the night. And they're finding problems with this now in a lot of these big distribution centers that are being constructed in in the inland empire where it gets very hot during the day. And so they like this for cooling. It takes a long time to heat up, but now they're running these distribution centers all through the night, and it's really getting hot at night in there. So tilt ups are very good. They go up quickly, comparatively quickly. They're strong, they're sturdy, they're very durable, and and if you have really qualified contractors, they're very, very reliable. In other words, you know exactly what you're getting, strength wise, stability wise, thermal wise, water vapor wise. Very, very good. The other one for light commercial, and again, this is usually 3 or 4 stories, are CMU, concrete masonry units. We use some brick in Northern California and some adobe, and those could be considered masonry units, but concrete masonry units are really, really common. They're nice because they can be also thermally treated with air pockets. You can put rebar in them. You can fill them back up with dirt or with other things with thermal properties that you know of. And they can be used in conjunction, like you see here, with a steel and concrete building. So these are probably concrete pillars that are poured with rebar in them. And this is probably concrete decking floor where there's some sort of a joist system like this with a sheet metal deck with concrete poured on it. And that makes a very, very good, strong, stable structure that is waterproof. It's very good thermally, very easy to control the air and water. Very, very leak resistance in general. Not so good in an earthquake zone. So there are places where you will see this, particularly in earthquake areas in California where they shy away from CMUs. But for light commercial, they're still pretty good because they don't get too tall. Okay, so our last one then is industrial, where you'll see steel. Steel is a huge product. A10 is the name of the type of steel that's mostly used in here. It's a version of ASTM 1020 or 1018 steel, 10 being carbon steel, 20 being the percent carbon, 0.2%, 0.18%. And so you can look at the steel, and there's channels, and there's wide flange beams, wide flanged beams. There's C channels, there's T-bar, all sorts of cool shapes, and we'll be looking at that a little bit later when we talk about sustainability probably. But you can just look all of those up, steel and concrete, how they're used, where they're used. But the building envelope then has a structure, a frame, which we're calling walls. Okay, and the walls are covered by a skin unless it's poured, and that skin might be wood, it might be glass, it might be steel, it might be aluminum. The structure of the skin is really important, but it gets hung on the wall frame. Okay, so, and these will be steel, and often there's concrete to cover these or to help add a little bit of strength in compression if it's deemed necessary. So that's a little bit about the types of construction that you can see. You should know that there is wood, and we've talked about it, Doug fir, larch hem fir, and you've seen some of the tables about them, and we're going to look at them in a minute again. You know, there's something called light metal frame, and it's usually aluminum or some 1020, 1018 steel. There's concrete, there's concrete masonry units, and then there's steel A10 being the most common structural steel. And the A10 just goes along with a certain style and amount of inspection that happens to make sure that the material used in creating that steel was correct and that it was processed in such a way that follows the standards and gives you very reliable and repeatable and weldable material. Okay, so that's a little bit about building materials for structures. Let's take a look at wood framed walls. That's the one that we want to work with first. And there's two types of framing. And if you look in this APA advanced framing and do a little bit of extra research in there, you're going to find, well, I'll just go to the one that's shown here. You're going to find the difference. There's conventional framing and there's advanced framing. Conventional framing, advanced framing. You'll see that the advanced framing uses less wood overall. Okay, so it puts it farther apart on center, and it does a little bit different type of blocking where and headers where the windows go. And in particular, it really saves on those headers and on the sill plates. Okay, and where doorways go. So it's much easier to put much less wood in a doorway for advanced framing. Okay, so they call it advanced because they require certain calculations to be done. So here's some of the differences: conventional versus advanced, 2x4 or 2x6, and remember, that's in dimensional lumber. A 2x4 is 1.5 by 3.5, and a 2x6 is 1.5 by 5.5. Right, so that's the nominal that you're seeing right there, and the dimensioned lumber is a little bit different. But it's wood framing, and it's 16 inches on center, so 16 inches between each one of the studs from center to center. And advanced framing uses only 2x6, 24 on center. Now, one of the reasons for that is with 2x4s, when you drill for your piping and your plumbing and your electrical, you drill certain size holes, and if you really want to do a pretty fine job, you'll put what's called a striker plate in front, or a striker tube in that hole. And that's basically a small steel piece of steel tube, so if somebody drives a nail, it gets deflected and it doesn't go into your pipe or your piece of wire. And believe me, that happens a lot if you don't do it. Well, that requires a slightly larger hole, and that degrades the strength in compression of your stud. So they just say, nope, you're going to use 2x6, and that's it. But to help save material, we're going to go to 24 on center. And since it's 2x6, you're going to have plenty of strength, more than enough strength. Normally, there was a double top plate on conventional framing, but they're going to use a single top plate. They would use 3 stud corners in a certain fashion to make a corner, and here they'll use 2 stud corners. Okay, and jack studs and double or triple headers, that's around windows and things like that. And cripple studs. These are called cripple studs. Okay? And so they use a minimal number of cripple studs wherever possible. Okay, so those are some of the things, and it's all about trying to reduce the amount of wood that's used and still have a good, strong, well-engineered frame. Right? So, and it does work. It works very, very well. Many places are going to advanced framing. And if you're doing a building design and you want to save some resources, that's what you're going to try to do. You're gonna do your drawing and you'll say advanced framing or conventional framing, and that will let the contractor know what to do. Okay, so there's cost effective. It is less expensive. You know, material costs can be reduced by up to 30%. Well, it's not normally gonna cut by 30%, but it's more, right? You got to have a perfect set of modules. Okay, it does meet green building strategies, so that if you're doing a lead design for a green building and you say advanced framing, you're going to get credits toward your LEED certification. Or if you're doing Cal Green, which everybody has to do, at least you're going to get your meet your requirements for sustainability. There are other ways to do it, but this is an easy way. Look at this. You join this group and you have all sorts of CAD resources for framing designs and details. Energy efficiency, they usually consider that because of the deeper wall. A 2x6 is more energy efficient than a 2x4. Air is a great insulator, believe it or not, especially dead air. And so a larger air pocket is good, and fewer travel paths. The wood is where energy can travel, and so the fewer travel paths, the better. So you do get better work there, and you can put in thicker batting, insulation batting too. So there's all sorts of things about that right here. Better insulation, tighter building envelope, fewer framing members, gives you a tighter building envelope. Tight means how much air leaks out at joints. So wherever you've got a joint, air can leak out. And so they wrap buildings and do all sorts of stuff. But in general, the fewer places where things join, the fewer places there are for air to leak back and forth. Now, you can have a building that is too tight, where you need some breathing in your building. But that's not just basic resources, that's architectural design. So this guy is pretty cool. This is a pretty good one, and you can go and watch that. My expectation is that you look at some of these things. Go to the resource library and, go to the FAQs and just find out what's, how do I look at the stamp on an APA trademarked OBA? Isn't that cool? So Engineered Wood Association, all this kind of stuff. So that's kind of cool stuff, right? How do I look at these stamps? These stamps are really important, and inspectors will look at these. As a matter of fact, you can't see it right now, but my ceiling is an undersurface of a floor, and it's just got sheathing stamps all over it. Okay, so this is rated for 24 on center. Okay, so there have been tests and studies and design done, And so this material is rated for 24 on center. Here's 24 on every 48. This one's rated for 16 on center. You would not use this one on advanced framing. You would need 16 on center. And the structure of your paneling will help you understand that. Okay, sized for spacing, 24 on center. Okay, this one's set for exposure 1. It's got an actual thickness of 0.703. They would call that 3/4 inch when they stick it on the shelf, but it's really 0.703. Okay, 0.322, they would call that 3/8. Okay, 0.375, but it's really 0.322. Well, 11/32 is what they call it. Okay, but when they throw it on the shelf, they always put it up bigger. So this is how you read these, the span rating, particularly for flooring. Okay, how far apart can it be? Whether it's tongue and groove, in other words, they lock together a little bit on the edges. So this one is tongue and groove. Okay, so they don't just butt up. You have to have the tongue and groove mating parts, and that just helps things go together and seal and not warp and split. Decimal thickness, bond classification. You know, what can it withstand for weather without just kind of like coming apart? Performances. So this is really, really powerful, good information. This APA site is awesome for that. Common framing errors. What can go wrong? These are things that can go wrong. Okay. Why does it feel bouncy? Oh, look, that one's missing some stuff. This is what a building looks like. Inconsistent materials, not always using the same things. Floor vibration. Here's some cool publications that you can go to. Misunderstood ratings. Get. So, as a material resource professional, when you're doing your designs, or if you're helping a designer pull together the data packs that go with a design, you might be going and getting stuff. This one's a great one to know. Really, really important to know this site. And here's all, and look at all these publication categories. Product standards. Right there, that's a great one to be talking about. And look, these are free downloads. Free downloads. This is where you're really getting into it with framing. This is an incredibly good site. So my hope is that when you do your portfolio, you show that you've done more than just read this, but you've kind of cruised around on this site a little bit. This one's a really good site, and show that you've looked at some good information. Adhesives for glue lam timber. Okay, and we might poo-poo glue lams, but they're specified. You know exactly what you're getting with a glue lam. They're not that good for the environment in a way, but you can, because they're so well engineered, you can work with smaller wood and not have to cut your big stuff. Cross laminated timber. This is a great site. Figure out what design and build means. Low-rise construction, panelized roofs, retrofits and models. Great source here. Okay. We also have the WWPA, which is another good association. Both of these associations are consensus groups. They have users and suppliers and specifiers and inspectors. Everybody's in these two. Okay, so there's all sorts of good stuff. There's a technical support grading rules. So, that one you got to purchase. Okay, but there's the resource library, and you can get some good stuff about here. Okay, let's see what their grade rule book looks like. I think you have to purchase these ones. Okay, but look, we usually talk about Doug fir or larch or hem fir. Those are what's most common. We get a little bit of redwood still. We don't get much white fir, and we don't do too much with ponderosa pine. In our area, it's mostly Doug fir larch or hem fir. Okay, so a lot of stuff that you can get from here also, and you should be looking at that. Here's this Canada. I hope it's going to come up. It came up the other day. There it is. So this is a Canadian grade, but you know what? Most of our lumber now is coming from Canada again. We've sort of lumbered out Northern California and Oregon and a lot of Washington. We can still get into some of the other western states, but a lot of our lumber is coming from Canada. So you can look at their grading rules and see what's up. And I'd just like you to kind of go around here and kind of see what's available. Here's some publications, general provisions, dimensioned lumber. There we go. That's really what we talk about, dimensioned lumber, a lot. And so look, here's a lot of classification: light framing, studs, structural joist and planks, 2-inch through 4-inch thick, all species. So this really talks a lot about these things. You can see somebody just did some PDFs so that you can pull these off and get these reading. But these are all the specs on these things. There's page after page after page of structural select structural, number 1, number 2, number 3. So you can go through this and really get a lot of information. Okay, so that's there for you. This is a really great resource also. This one on grade stamps is really important. If you're an architect, you live and die by these, and so do inspectors. When they come in and they look at a wall before it's been sheetrocked or finished, they're looking for nailing patterns to meet standards, and they're looking for stamps on each piece of lumber to make sure that it's proper and it's appropriate. So here you'll see, for instance, it's a Doug fir larch. It's standard green. In other words, it's not been kiln dried or anything. It's 1 or better. It's Western wood product, and this is the lumber yard it came from. So you can tell a lot from this, and they're going to be looking at this. If you call out a certain stud or a certain joist or a certain rafter, you're going to be calling out the grade. And it could just be in a note, or it could be on the detailed drawing, or it could just be, per standard. Either way, there's lots of ways to do it. But this is what we're looking at. We're looking at, there's the certification mark. One of the WWPA inspectors actually went and inspected that lot and then put their stamp on it. Okay, there's the mill identification. Here's the list of mills. You can actually go through and find all the all the, it'll come on in a minute, I think. Um, Usually that pops up. I don't know why that link looks like it's broken right now. Grade designation, standard, select, and better. The species is always in this triangle. And then the seasoning. Seasoning, this one is dried. Okay, and these are different types of MC15 is moisture content 15%, kiln dried 15%. This is really important. If you get wood that's too dry or too wet, it's going to warp on you. And so you want it to be appropriate to the environment you're building in. So here's standard dried, kiln dried, 19% maximum. S green is over 19% unseasoned. So this is a really, really cool one. There's the mill list. Let's see if there we go. That one came up. So these are certified WWPA mills. This is where you can go, where they actually bring all the wood and cut it up and do it. And so you can see there's shows a lot in California, but many of these are no longer active mills. Okay, many of these are not active anymore. Okay, so that's a little bit about the grading. That's really important that you understand. Need to look at these. You go to Home Cheapo, you'll still see these on there. Although it's hard to find the one and better at Home Cheapo. Okay? And you'll most often find S green. And it's, you know, there's a certain, these have a certain amount of warp and all sorts of grade. Here, let's see what their grading rules say on here. If we can, you have to purchase their grading rules. Okay. And so then there's also minimum properties that go with it. And as I read this, it says the size, and this is really interesting. Look, a 2x4 has a higher stress. Let's pick number 1. It can take 1,850 pounds per square inch. And here in number 1 is 1,650. Isn't that weird? Let's go to a larger one. Let's take a look at this. A 2x4 can take 1,300. I want to find my 2x6. My 2x6 can take 1,450. It takes less. Okay, and that's because that's because there's more chance of having a knot that you can't see. So these are the stresses. Extreme fiber stress. That's at the outside edge, and the fiber stress, as you try to bend it, it can handle this type of a load. Tension, pulling straight on it, parallel to the grain, it can take this type of a load. And horizontal shear, it can take this type of a load. So these are important if you're doing a design that does not already exist in one of those tables. Remember a couple of weeks ago, we looked at the span tables and in the flooring. And the span tables include this information. It's all been put into it. So instead of having to work it out for yourself, you can read it out of a table. But if you have a situation that does not match the table, you want to take a look at these. And there's parallel to the grain, and then there's horizontal to the grain. Okay? perpendicular to the grain. So these are important numbers. Look, ooh, standard wood size. Here's the standard sizes. So many places you can go here. Look at that. If you think you got a 2x4, it's actually for dimensioned lumber, 1.5 by 3.5. You can even get the weight per foot. And look, it goes like that up until you get to anything over a 12 by is going to be actual sizes. They don't do this on everything over a 12 by. Cool. So there's your, and let's take a look at some nailing. These are the identification charts so that you know what these lengths are. So, and these have to do, again, you'll look at standard tables that will tell you, okay, I've got this size ledger, I've got this size header, I want this size nail, and this pattern. It's all in tables for the framer. So in general, the architect will just call out a certain standard, and then the contractor has to go to these standards. But you need to know about that so that you don't just let somebody go willy-nilly and start moving along. Okay, so this is how you find them. And you can measure them out. Cool. So this is just some good information about wood wall framing that I'm hoping you go and check out and look at. Here's a little bit about sizes again. I think we just looked at that one. And this is about the grades again. I think I got some things in a couple of different spots. That link might be broken. Looks like that one got broken. Okay. That's about your wood framed walls, some of the styles and terminology and the things that we've done. Advanced framing, conventional framing, and then a bunch of the terminology is all buried in here. So let's look briefly at windows. There's styles to look at: single hung, double hung, arched, awning, bay, casement, transom. There's actually 18 official styles that I know of. These are the most common ones, and I'd like you to go look at those and show me that you've understood what those all look like. Okay, and then there's grids and muntins. That's what these little things are. There's the frame or the sash, the part around it. And then there's the glazing and the filling. The glazing is the glass and what goes in there. You should know what the term low emissivity means. Okay, and U factor and solar heat gain. And I've got links so that you can just go look those up. But this is what you want a window to do. Low E glass does this. Okay, and it does this, and it does this, and it does this. Okay, it reflects winter heat back inside. It reflects summer heat outside. It lets the visible light pass through, and the UV light is reflected. And this is what's called double pane, because there's two pieces of glass with some sort of inert gas in between. And then you'll look at some of these things. Boy, keeping water out. how do you keep the water from getting inside and leaking? It's a big deal because water is going to be pounding against it. And this is what all that sealing and stuff might look like, and the frames and the flashing and how that all works. It's pretty heavy duty stuff. Here's the glazing and some seals and some more seals and some more seals and some framing. Woo! A lot of stuff going on there. And ASHRAE is a very important group. Okay, so they're a standards organization too. So these are just some of the things that you should be looking up and really putting some information in about these to show me that you understand what is a grid or a muntin, what is a frame or a sash. And you can go find those things and find others. Remember, you're not to use my examples because I've done all the work to find those ones. You find other examples and show me that you know what low emissivity means. Show me that you know what U factor means. And show me that you know what solar heat gain coefficient is. And these descriptions are pretty straightforward. They're pretty good. I don't know why I've got this one on here. Let me delete that one. I said I would delete it. That one should have been gone. So our last thing to go over here is about doors, and it's the same type of a thing. Doors are really tough. If they're built one way, they might warp. If they're built another way, energy might pass through. If you built another way, acoustics can pass through. But if you build it so that it's an awesome door, it's usually expensive. There are fire doors, there are interior doors, there are exterior doors, solid core doors, hollow core doors. So all of these things, but you should know under door construction, what's a stile, a rail, a mullion or a muntin again. What are the panels? I don't know why that says lighting. Oh, that's your side lighting. Do you have side lighting or transom lighting? What is hollow core, solid core, and what is the skin or the door facing? So those are all things that you should know about, and they're all different, man, I tell you. And the materials, you can find wood and vinyl and steel and aluminum and combinations of all those. You can get fire rated doors, interior doors, exterior doors, but these are the big ones: wood, steel, and vinyl and aluminum. And then fire rated doors are important. Even on a residence, your exterior door should be a fire rated door. I actually, in one of my previous jobs, got to visit Underwriter Laboratory testing facility in Northbrook, Illinois. It's a huge facility. They got warehouse after warehouse after warehouse. And my tests on some water valves were done in the same building as they were doing UL listed fire doors and fire windows. And I got to see a fire door test. And the guy who ran the test had the best job, I think, in the entire world. So they had a door and this thing that looked like a bazooka. And they'd roll the door across like a barn door. And it was a fire door and it was steel. And it had a little window in it that you could look through. So it was sort of like a classroom door or a hospital door, where it was steel, but you could look through. And they were testing the fire rating. And so this was the coolest thing. They started up the fire. It came jetting out of the tube and blew at the door, this huge flame. And the tube was about 8 inches in diameter. So this flame shot out of the tube and about across a 6-foot gap and hit the door and just started just flaming that door. And then they moved it up until it was shooting right at that piece of glass. And they kept it on there for about half an hour. And then they took a fire hose and blasted it at that piece of glass while it was still burning. And they did that for half an hour. So the fire plus the water. And then they turned it off. And after an hour, if that door would still open and close, it was a 1 hour fire rated door. What a flipping cool test. And whoever got to build that test equipment and run it, I think, has the best job in the world. So cool. I got to see some other cool fire tests while I was there. And at some point, I'll tell you about them if you ask. But that was really something. So, again, you should be able to show me that you understand what these things all are. And again, you can't just use my images. You have to go find your own images to show that you looked them up. And you might put a better description than just style. You might do something like, and you can look up on this Explorer down here. Let me do that again. Search. I can find all sorts of images that might point at them. What are styles? Styles are the vertical pieces of the door. So as you put yours in there, you might put styles are the vertical pieces of the door and put that up with it. Do more than just put this in here. Okay, look to see that you've done some of these things. Door, Muntin. Divide a window or sash. Look and see what that lights. Oh, these are Muntins. These are Muntins. Cool. Okay, so you can look all those up and kind of play around with it. Okay, there we go. That's what I wanted to cover for today. And I look forward to seeing your excellent submissions at the end of the week. And again, remember, if you need to get a hold of me, you can always go and catch me on my appointment schedule and catch me at a free time. Okay, so there we go. Thank you very much. Excellent work, everybody, and I look forward to seeing your great work. Bye.